We've been seeing some really incredible things with LLM-based autonomous agents. They're tackling all sorts of tasks.
Absolutely. The capabilities are just skyrocketing.
But let's be honest, real-world problems, they're complex, often much more complex than one agent can handle alone.
Exactly. And well, as soon as you start talking about multiple agents working together, you hit these two big hurdles.
Right. Which are?
Well, first, how do these different agents, maybe built by different teams, actually talk to each other? Like effectively.
Okay, communication. Makes sense. And the second,
And second, how do they connect to the outside world? The tools they need, databases, APIs, web services, stuff outside their own system.
right. Otherwise, it's kind of the Wild West, isn't it? Everyone doing their own thing.
It really can be. But thankfully, we're seeing some really crucial steps towards standardizing all this.
And that's what we're diving into today, isn't it? Two key protocols.
Yep. We're looking at Google's Agent-to-Agent protocol A2A that came out, April 2025?
Yeah, April 2025.
Hmm.
And also Anthropic's Model Context Protocol, MCP. That one was a bit earlier, November 2024.
So our mission for this deep dive is to, really unpack what A2A and MCP actually are. What do they do separately?
And crucially, how they fit together.
Yeah,
Because that seems to be the key to building these more sophisticated, practical agent systems we actually need.
exactly. How they combine to solve real problems.
Okay, let's tackle that first challenge then. Agents talking to other agents. How does A2A help there?
Right. So A2A is laser focused on that. It provides the standardized language and structure for agents to communicate with each other.
A common language?
Pretty much. And one really interesting piece the sources mention is the agent card.
Agent card, what is that, like a digital business card or something?
Precisely. That's a great way to put it. It's how an agent describes itself, its capabilities, its purpose, what kinds of tasks it's good at.
Ah, so other agents can find it dynamically.
Yes. Instead of having everything hard-coded, agents can discover who else is out there and what they can do. It's really fundamental for flexible collaboration.
Wow, okay, so an agent basically advertises, hey, I'm good at stock prices, and another agent can find it. That is where it gets really interesting for multi-agent systems.
Definitely.
And beyond just finding each other, how do they actually structure the conversation itself?
Well, A2A also defines a structured message format. It's not just random text flying back and forth.
More formal.
Yeah, it specifies how messages should look, headers, body, different content types. The structure is key for things like, clearly delegating tasks, getting progress updates, even secure communication.
Okay, so A2A handles the agent-to-agent stuff. What about that other piece connecting to the outside world? Tools, APIs, databases.
Right. That's where MCP, the Model Context Protocol, comes in. If A2A is the internal chat network.
MCP is the external line.
Exactly. MCP is all about how an agent connects with and uses external tools and resources. It standardizes how agents understand and, importantly, use these outside things correctly.
And the sources mention specific features for this, like tool descriptions.
Yes, and critically, using standards like JSON schema, this gives the agent a really clear, structured way to understand a tool's interface.
Like a precise instruction manual.
Kind of, yeah. The agent knows exactly what inputs the tool needs, what format, and what kind of output to expect back. It adds a layer of predictability, safety even.
Got it. So the agent understands the tool via the description.
Yeah.
How does it actually use it then?
That's the other key part, the standardized function calling mechanism.
Okay.
This defines the process, how the agent selects the right function on the tool, how it formats the call with the right parameters, how it actually triggers the tool, and then how it interprets the results that come back.
So it standardizes that whole interaction. Agent thinks, tool acts, agent understands result.
Precisely. It bridges the agent's internal logic with real-world action via these external tools.
So let's pull this together. A2A for agent-to-agent, MCP for agent-to-tool. They sound like they solve different problems, but are they designed to work together?
Absolutely. The sources really stress this. They are complementary. They form a kind of foundational layered architecture for agent systems.
Layered architecture, like Legos.
That's a good analogy. A2A lets you snap different agent blocks together to collaborate. And MCP gives those individual agent blocks the ability to grab and use specific accessory pieces, the external tools.
Makes sense. A2A handles the who does what and the internal coordination. MCP handles the how to use this specific external thing.
Exactly. And we can see this super clearly in that stock information system example described in the source material.
Okay, yeah, walk me through that. If I ask an AI system, what's the latest news and price for, say, Google stock? How would A2A and MCP work there?
Okay, so your request probably hits an orchestrator agent first. Its job is to figure out the plan. It uses A2A to say, okay, I need the price and I need news. So it sends A2A messages to delegate tasks, maybe one to a specialized stock price lookup agent, another to a news agent.
So A2A for delegation. Got it. Then what do those specialized agents do?
Now they need external data. The stock price agent, using MCP, connects to a financial data API to get the current price.
Okay, MCP for the API call.
The news agent uses MCP to query maybe a news aggregator's API or scrape a relevant news site. Again, MCP defines how it uses that external tool.
Right. They each use MCP to grab their piece of the puzzle from the outside world.
Exactly. They get their specific data price from one, news headlines from the other.
And then they send it back to the orchestrator.
Yep, using A2A again. They send the results back in A2A messages. The orchestrator receives these pieces, again via A2A, puts it all together, maybe summarizes it,
He gives me the final answer.
and gives you the final answer. It's a perfect loop. A2A for internal collaboration and task management, MCP for interacting with the necessary external resources.
That really shows how combining them moves agents beyond just like theoretical exercises.
Yeah.
They can actually fetch and synthesize real-world up-to-the-minute information.
That's the core value, really. A2A and MCP provide that standardization for communication and tool use. It just makes building these complex, collaborative AI systems so much more feasible.
And presumably faster, more interoperable.
Definitely speeds up development, makes systems more robust.
So these protocols, they're not just ideas. They're pushing agent tech towards, well, real services, right?
Yeah.
Things we might actually use.
Yeah, the sources point to applications emerging in areas like recruitment, customer support, even helping with code reviews, anywhere you need coordination and access to external info.
Which leads to a pretty interesting final thought, doesn't it?
Hmm.
Well, what happens next? What new possibilities really open up when you have AI agents that can seamlessly collaborate and effectively use pretty much any external tool or data source out there?
It definitely makes you wonder about the complexity and the capability of the AI systems you'll be interacting with, probably sooner than we think, every single day.